My name's Alistair Russell. I'm from the Cement and Concrete Association in New Zealand, and we're here at CCANZ Precast in Papakura in Auckland. Today we're going to be seeing best practice of concrete production within a precast factory. So we're going to be seeing concrete being delivered, placed and manufactured into precast panels, and this is a demonstration of best practice of concrete in the New Zealand concrete industry. The first thing that happens in a construction site is the delivery comes in. So we've got the reinforcement being delivered off a truck. It needs to be deposited in the correct location. So when the longitudinal reinforcement is first laid out, usually a panel is longer than the bars themselves. Those bars need to be spliced together. If the shop drawings show that the splice needs to be 1.5 meters, then that splice needs to be 1.5 meters. And so the splice needs to be tied together tightly. It needs to be a contact splice. So the two long bars need to be in contact together as shown in the video, and then tied to the transverse bars going in the orthogonal direction. Once the reinforcement is laid out on the ground, the transverse reinforcement and the longitudinal reinforcement in the other direction needs to be assembled together. The way that's done is it's tied together with these thin wire ties. This can be done manually with a pair of wire clippers as you can see here, or it can be done with an automatic machine which puts a tie in place and automatically ties the knot at the end. So the grade of the reinforcement is often written down on the reinforcement bar itself. So this says seismic 500E. If it's E, it also means seismic. There's also a generic bar marking shown on here. So you've got a gap, and then next to it you've got the two lines, and this designates this bar as being a grade 500 bar. In addition to this, reinforcement often shows the type of manufacture that was used in making the bar. This says MA, which means it's a micro-alloyed bar. Grade 500 reinforcement, you really need to know the type of manufacture that was used, because this affects what you do with reinforcement, if you can weld it or the way you handle it as well. In addition to this, it should be shown on the docket when it's delivered what the type of reinforcement is, but if that gets lost or you don't know where that docket is, this is what you're looking for, which tells you how you can handle the reinforcement on site. So we can see that this bar here is a grade 500 bar. Even if we can't read what it is, we know that it's got that marking. I've got this handy bendometer which tells me how tight I can bend the radius of this bar. So I put the inside part of the bendometer on the bar, so I know it's a 16mm bar, and then the outside of the bendometer is how tight I can bend the inside of the bend radius. It also says it's a 16mm bar, but the bendometer allows me to see what the diameter of the bar is, and therefore what the bend radius, allowable bend radius is. If the bend is tighter than this, then we actually get a build-up of strains on the inside, and you can get a fracture or a bar rupture at that point there. So it's very important to observe the bar radius and the minimum bend. So whilst this is also grade 500 reinforcement, we can see by the marking, and it says grade 500 here, this is a very tight radius. This is tighter than what we're allowed to have using the bendometer. It's a 16mm bar, 16mm, but the bend of the radius at the end of this bar is much tighter than that. The only place that you're allowed to have such a tight bend is at the end of the bar when it forms a stirrup. So this is a stirrup at the end of the bar, and other parts of the bar you need to obey the limitations of the bendometer. Now normally reinforcement comes onto site pre-bent from the manufacturer, from the supplier, but it's the responsibility of you when you receive the reinforcement on site to make sure that it complies with the minimum bend radius as shown in the bendometer. So in this case you can see it's too tight, but because it's a stirrup at the end of the bar, it's okay to have such a tight bend. So normally long bars are made of grade 500 reinforcement, and that says on it grade 500 with the appropriate marking. In this case you've got grade 300E, so this identifies this as a grade 300 bar. Grade 300 is usually used for the stirrups, and it doesn't have quite the same requirements for the bending and the handling that grade 500 reinforcement does. So when the formwork is constructed, it's very important that it's well supported from the outside. So in this case, we've got a nice clean timber surface on the inside. You can see the nice clean timber surface here. And even though this is only going to be about a 200mm deep panel, not a very deep panel, the pressure, even from 200 millimeters, is enough to bow out the timber, bow out the formwork, so it's very important that it's effectively supported from behind. Prior to placing the concrete, formwork has a release agent applied to it. This is kind of an oil which functions as a bond breaker between the formwork and the freshly placed concrete. When it comes time to remove the formwork from the concrete or to take the panels out of the moulds, which usually in a precast yard is in the next day or so, the two can separate without sticking. Once the formwork's been assembled and covered with the release agent, the reinforcement cage is then brought into place. In this case, it's craned in. It's deposited with the chairs pre-attached to the reinforcement cage to make sure that the reinforcement's at the right depth, providing the correct cover to the reinforcement. So these are the chairs that we've been talking about. This holds the reinforcement in place. It holds it at the right depth away from the edge, and this is what ensures the concrete has the correct cover. So once the cage is put in place, the final detailing is done, the final tying is done to make sure that the cage stays in the right place, and then the concrete can be placed afterwards. Concrete for precast work is delivered in generally the same way as in any other concrete site, in a ready-mix concrete truck. When the truck arrives at the site, in this case it's inside the precast yard, it needs to do a final mix to eliminate any small amount of segregation. It's a good idea to put down a small piece of board to break up the initial fall of the flowing concrete and also to stop any impact onto the reinforcement cage. So generally you should start pouring the concrete into the furthest points away from the truck or the chute and then move progressively backwards. This means starting the far corners and filling up the mould from that area back towards the truck. So once the concrete's been poured into the moulds and spread around to fill up all the spaces, it needs to be compacted. Usually this is done with an immersion vibrator, and it's important that this reaches to all the concrete and that no points are left unvibrated. The compaction should be done systematically, moving throughout the freshly laid concrete in an organised sequence and not randomly. Each area of concrete should be vibrated around about the same amount, and the vibration device shouldn't be left in any place for too long. Once the vibration or the compaction has taken place, the initial screeding should happen immediately. This spreads the concrete out and is the first pass at levelling the concrete surface. After screeding has achieved a level surface, floating is the next process, and this can be done by hand or using a bull float. Throughout the placement of concrete, there must be someone on hand to observe and record the quality of the placement and to tick off all the necessary steps in the process. Once the concrete's firm enough to walk on, you can use a machine-operated power float to work the top layer of the concrete to achieve a hard surface. In a precast yard, the panels are usually lifted up within about 24 hours after they've been cast. So this panel would have been cast yesterday. You have the cast in the lifting lugs or lifting eyes, which is what the crane attaches to. And then this panel will be lifted up, removed, taken to the back of the yard and then stored until it's delivered to the construction site. So once the formwork's been stripped from the panels, they're then lifted, transported and brought out into the back of this yard. In this case, they're sitting here ready for delivery to the construction site. They'll be picked up by a truck and taken out to that particular construction site. CCANZ would like to thank Wilco Precast for their kind permission in letting us use their facility to show best practice in concrete construction.